Part 3. So let's pretend we have our perfect segmentation. I'm going to use the otolith, which is not an otolith. Show it in 3D. Okay, this is our segmentation. It's kind of random, but I'm going to use it to demonstrate my point. So let's say this is our perfect segmentation, and we're going to now use it for some project where we want to visualize our segmentation alone. So the way we're going to do that, and the way we're going to save this forever and ever, is something I just recently started doing is going to be our first step. So I'm actually going to turn off the 3D, and I'm going to dilate this by the smallest step possible, which is 3. Because I don't want just the edge, I want also a little bit beyond the edge. Because what we're doing is actually we're going to make a volume just like this, the same kind of file, but only the segmentation. So this is what we want. Unfortunately, if we were really doing this, we'd have to go through and make sure we didn't make another connection with a bone. You probably will have made a connection with the hyomandibular. If you do that, which won't matter, it's not going to connect, it's not going to create this hyomandibular again, because this will be not selected, but it will have probably connected it to where there's a little bit of bone that belongs to the hyomandibular hanging on to the neurocranium, for example. And when you see that in 3D, what that will look like is really bright white bone, because you're actually inside bone and you have bone sticking to the structure that you want. So you'll probably have to go and clean that up after. But once you've done that, once you've cleaned that up and you're ready to go, you have your edges. They're not just the edges of the bone, but just a little bit beyond it. So you have that, this, what do you call it? Histogram that goes from black to white. When you've done that, you want to create a volume that is just your segmentation. So the first step is to turn this original volume off, select it, and hit the second icon that copies it. So copy it. And depending on how big your data set is, it'll take some time, probably. You never edit, because we're going to edit this volume. You never edit your original volume, because you might need it down the road. You're not like destroying your data, your raw data, because you have that somewhere else. But if you need it down the road in this project, and you have edited it, you can't undo that. So we always make a copy. And it takes a little bit. This particular data set is 27 gigabytes. All right, so we have a copy. So now we have almost 60 gigabytes tied up in this, which is a huge amount. We're going to double click, and that allows you to edit the name. It'll add copied to the end, but it's too unwieldy when it's this long. So I'm going to say it's data copy. Or if we were doing the neurocranium, because ultimately this will be our neurocranium. I will name it neurocranium. And I will activate it by hitting the eye and click otolith in a world where otolith is neurocranium. So I'm going to change the name to neurocranium and pretend that we have perfectly segmented the neurocranium. Okay, we want these things only, but we can't really do that in a direct way. So what we have to do is we tell it invert. So select everything that isn't selected. Then we have these operations down here, image operations. You must change this to your other data set. This is the data set we're going to manipulate. I changed it to neurocranium and I want to override it. And what I override it with is a value of 0. And then you hit OK. Everything selected vanishes. Doesn't exist. Those voxels do not exist. The dimensions of your cube are the same, but there's nothing inside that cube now where the yellow is. Now, if you ever want to use this segmentation again, you want to invert it again because you want to put it back to normal. And then deselect it because you're done with it for now. Now what you have is a volume, just like the original volume, but you have deleted everything that isn't your segmentation. So we can see it in 3D. Yeah. We're missing a lacrimal and stuff like that, right? And an otolith and part of the jaw. Just like that. So let's say we had just the neurocranium. This clipping box, we're going to use it to change the dimensions of this data because right now it's the original data dimension. If you export this now, it will also be 27 gigabytes. But if you have segmented something like the neurocranium, you can get right up there. You can watch it until it cuts in. Actually see when it starts to cut in there. Get really close as possible. You want to spend a lot of time here because when you use this later on and store it, you want this to be as small a file as possible. So we have our fish like this, but we can't fix that, believe it or not, as far as we know.
Yeah, so that obliqueness is caused by us or me mounting the fish in an oblique way in the container, and then it's scanned this way, and you can't change that later.
Yeah.
So it's best to mount it in a straight way, which isn't always possible.
Okay, so we've mostly gotten it ready except this side. Then you right click and say modify and transform, then crop. Always keep create new selected. It's not ideal because you're creating yet another volume, a third one, with these dimensions. But I've noticed that quite often the crop fails for whatever reason, and it leaves you with an error, a volume that has some error. So it has a question mark where this icon usually is. There's like a question mark or an X, and it's just unusable after that. And then you have to start over. So if it does that, you can just delete the one you made, do it again. So always create new and apply. This will crop. It doesn't usually take a super long time. Okay. Now we have neurocranium cropped, and it has this icon, which means it's a volume. It's fine. Get rid of the clip box. And now that you know this one is okay, you can delete this intermediate volume, this neurocranium, just delete it. There's a little trash can on the right. Delete. Okay, now you have a volume that is just the neurocranium. If you want to send it to someone or use it on a different computer or export it to a Mira or blah, 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 right click, export images, and create a folder. If you don't, you will dump thousands of images into whatever folder you have selected. So say new folder, neurocranium, open that folder, now name it what you want. I always name it what it is and the size that we actually can't see. So I didn't talk about this at all, but I will talk about it with the importing data. If you go to your volume, our original volume, and then image properties, you can find, where is it? Here, the spacing, which is very important. So this tells you the voxel size. So ours is 2.4, which is 2.4 microns, and that's the resolution we got when we scanned. So always name your segmentations, your files with what it is, ideally the fish it is, the structure it is, and the resolution. So over time, images, folder, already made a folder. There, for that. So I would say, racemic these, let's see this. Mocha cock, almost like the rooster. And then 2.4 UM. Yeah, mocha cock, not the parentheses ideally. Yep. Sometimes I have this option, apply WL and gamma. If that option is available and you don't click it, you have no gray values, you have black and white only. I have no idea why. If it's not available and you save it, let's just do it. It will actually have the correct gray value. I don't know why. Mystery. And then we'll see and when this is done, we can look at it. Also, see here is your properties of your volume over here on the right. So this volume, the neurocranium one, is 9,000 megabytes or 9 gigabytes. And this one is 27,000 megabytes. So when we cropped, we, cut it by a third, basically. Right. By 2/3. There's a 3 in there. So our volume is somewhere. Neurocranium, right? It's missing.
Maybe it's at the end, sometimes use things.
Try again. There it is. Weird. Okay. So what I wanted to show you is what it should look like, and also show you what happens when you have an oblique specimen. So ideally, these would be square, but really we have this oblique cut because that's how it actually is. So we're seeing how we're seeing the real, I guess, reconstruction. So yeah, you can see that this looks like you have gray values, you have black, you have, a spectrum of gray. Oops. So you're good. That's what you need. If this were wrong, it would be like all this would be white and this would be black, and it'd just be black and white. So you want to double check that. And that's it. Okay, with Odal, if you can see.
This you would either load into another program or send it to your collaborators.
Mhm.
So they can-
It is, I'm still actually not 100% sure that this is the, like, the reason why we have this rectangle is because it's oblique. I'm not 100% sure of that actually, because it doesn't seem like it was this oblique. This almost seems like a sagittal.
But you will always get, yeah, in the sagittal section, you will always get kind of a long rectangle rather
Exactly.
than square.
Exactly. But what you usually see with TIF stacks, what you normally see is the square because we're doing, well, because it's a cross section.
Transverse, yeah.
So I'm wondering if this is not some mistake. It doesn't matter in the end, I don't think. But if this is a mistake that I'm making in exporting these, or if this is really the reality of what the, I'm just not too sure about that actually, so.
So the original TIF stack was in transverse, right, in cross section.
There's no original TIF
Oh,
stack.
okay, somewhere else. Yeah, I wonder if you can select the plane that you would.
I haven't figured that out yet. So if anybody figures that out, that would be helpful. But I mean, when you look at the basic properties that it shows you this preview, that's the orientation that it is in, the original data. So I think it is just because it was scanned obliquely, but I'm not 100% positive.
And you would only do that really for that purpose, to pass it on to someone.
Yeah.
If you were to work on this data set in Dragonfly again, you wouldn't need to do that.
Right. Okay. I'm gonna pause this. Okay, what do you save and what do you keep as a project when you're working on this? In Dragonfly specifically, you want to always save as you go. If you're really spending a lot of time on something, I would save every 10-15 minutes. And it can take some time to save, but go ahead and save. And what you're saving when you do that is a session, ORS session. And that includes all of these things. Everything up here, all of your items up here get saved in a session, and a session is one file. So if you go, see here, we'll look at some of our things. We have different kinds of files. This is our file I'm working on right now, which is a session. When I last saved it, I only had the one volume and it was 27 gigs. So roughly your largest file is going to, you know, as you add things, it will add the size to the size of the session. So right now this session exists as 27 gigabyte file.
So if you segmented, let's say, 5 different complexes of the skull, it would it ever become larger than the 27?
Yes, if you have volumes. So my strategy is, once I have exported this volume, for example, the neurocranium, and I'm happy with it, and we check the TIF stack, I delete this from the session. But these segmentations, I never delete ever, because almost always you have to return to them because you have to fix something. There's something missing, or there's something that shouldn't be there. So if you, and they take up almost no space. In terms of file size, the segmentations take up almost nothing. So keep them and label them really well. Right now I have a bad example because I have two, name, and then I have faster neurocraniums. So who knows? Anyway, you would have a bunch of, so what you end up as you work is kind of, I would finish one, make this TIF stack, and then delete the volume out of there and then save. As I finish another, make a TIF stack, export it, delete that in here, and save. And save as you work on your segmentations, because Dragonfly crashes a lot. All of these programs crash a lot. 3D Slicer crashes all the time. Mira, I don't know, probably. Dragonfly does. And you don't want to lose hours of work. So what else? So what you would save, so in the end, if you finish a project, what you have from beginning to end, you have raw data from the scanner. You have your reconstruction or stitch if you have multiple segments. And you have an ORS session. And with segmentations and tip stacks. And that's kind of what you have. You can save. Something I didn't talk about is as this gets larger and larger, if you don't want to delete volumes, which I would recommend deleting them, you can actually export. So let's, you can export something as an ORS object. And then you can open that object alone in another session of Dragonfly. So let's say this ORS session got unwieldy and I wanted to take the original data and one of my segmentations, I would use control, select both of them and say export as either multiple ORS object or as an ORS object, which is a single file. It doesn't matter. Either way, you can open Dragonfly, drag those into it, and then you would have a new session with just those two things in it. And you would get rid of all of your extra stuff. Sometimes you have to do that.
What about taking images? Because that might be useful for you, I don't know. Yeah, think of a cross section or a theme or
Yeah.
these growth lines, and then you can take an image.
Okay. Along with taking images. So select your data. You're showing it in 3D. To take an image, you just have this little camera icon up here. Click that. Everything kind of goes dark. Then everything comes back. Export screenshot is over here. They're far away from each other for no good reason. Export screenshot. Then you can change your width and height. I think these are locked. Yeah. So it'll keep the same ratio. And the larger you make it, higher quality, higher resolution. Yeah.
But I guess what's given you as the default is already the 1 pixel, 1 voxel ratio. So if you increase that, you're actually not increasing the information content in there.
The DPI.
Yeah.
Yeah, you're just making it bigger. So yeah, you don't have the same control like you have with a Mira. So this other program has a much better visualization abilities. So let's say we just make this. You can do alpha background, which means everything that isn't data is gone, like a PNG. So test that, and then it will ask you where to save it. Let's just do it here. Has to pick, and then we'll see what that looks like. Yeah. So we have foam. Dragonfly has the ability to use some presets, and then you would change them here. So I have one I've made. Makes it look a little different. Each preset can either use, or each LUT, so this is a lookup table that's over here. It just says, I think it's called that because it says this range of the data, the color, I don't know, you look up the color. I'm not sure why it's called lookup table. But here's your not dense stuff. Here's your more dense things. And you can change all of these and just play with these until you figure out what you're doing. I always use this option piecewise. It just gives you more control over the opacity. So for some reason, you just have more control of it this way. So it's not just from down here, up here in a linear way, you would distribute your color across the gray values, however you think makes it look most realistic. Another thing, if you're cutting into bone to visualize it, use this clip box and you can drag in and see inside your structure. And then the options you have is to use lighting or not. This can be helpful or make it look more realistic as long as it's not too crazy. But you can also get rid of it. And then it looks like this and isn't as hard to manipulate for the computer. If you use lighting, it is really intensive in the computer. I've never used focus. It's horrible. Not sure why this exists. Imaging processing panel. I think you can get really involved with a lot of this stuff, but I haven't delved too much into it at all. You can make videos, which we did the other day, and I don't remember how to do right now. So that's another video, how to make videos. And what else? If you're really messing with the density, and say you only wanted this really dense stuff, but you don't want to drag all of these tabs over to redistribute your color map, there's a drop down option that says more. It says distribute color points equally. Well, that didn't do what it's supposed to do, but I thought usually it distributes it between your points here, but that's maybe not. Yeah, never mind. That didn't work.
If you want to take an image in 2D, you just do the same thing.
Right, so you would have you can just drag these across if you want to keep your color map, but you want to do it in a different density range. But you wouldn't really want to do that probably. Ooh, okay. Anyway. Yeah, reset. Yeah. What else? Let's see. If you want a scale bar in your image, you have to use a different kind of view. So this is not an orthographic view, but you have to click orthographic projection. It changes how it looks. Then click scale bar. And you can move your scale bar around. And you can change the details of the scale bar by right-clicking it. You can change your line style. You can set a specific length. And that's about it. So just a few different ways you can change it, but you can't use the scale bar unless you have this orthographic projection selected. Yeah.